Let's look at two questions based on graphs. Question 1. The count rate for a radioactive isotope was recorded for 600 minutes. The graph shows the results after adjusting for background radiation. What's the half-life of the isotope? So we need to find the time it takes for the count rate to drop by a half. So if we start at 240 becquerels, we could halve it to 120 and halve that again to 60 and halve that again to 30 becquerels. So the time it takes to drop from 240 to 120 becquerels is 150 minutes. And the time it takes to drop from 120 becquerels to 60 becquerels is 150 minutes. And to drop from 60 to 30 is also 150 minutes. So the half-life is 150 minutes. Question 2 is slightly more involved. The graph shows how the number of undecayed nuclei of a radioactive isotope decreases with time. And we need to estimate the activity at time equals 0 and then estimate the activity after 15 seconds. So the first thing to note is that activity is short for radioactivity. In other words, the number of particles given off per second. We know that every time a nucleus decays, it gives off a particle. Say we start off with 35 undecayed nuclei, and after 1 second, some of them have decayed. We can work out how many by looking at the change in the number of undecayed nuclei. Here, there are 30 undecayed nuclei left. Remember, the total number of nuclei is still 35. So the change in the number of undecayed nuclei is 5, which means that in 1 second, 5 particles must have been given off. 5 particles per second is an activity of 5 becquerels. So we have a general relationship that activity is equal to the change in the number of undecayed nuclei divided by time. Let's use that to answer part A. We know that the radioactivity changes with time, but the line is quite straight between these 2 points. The number of undecayed nuclei drops from 30,000 to 20,000 over a time of 4.5 seconds. So 10,000 particles must have been given off in those 4.5 seconds, which is an activity of 2,220 becquerels. Let's look at part B. We're going to use the same idea that activity equals change in number of nuclei over time. But the problem is that the line isn't straight at a time of 15 seconds. The rate of change of nuclei is just the gradient at that point. So we take a tangent and find its gradient, which is change in y over the change in x, or 18,500 divided by 25.5, which equals 725 becquerels.